Hello and welcome to our next lesson. It's Unit 10, Lesson 4 on inscribed angles and polygons. Please note that we did skip Unit 10, Lesson 3 just out of e-learning. That was just a piece of the curriculum we felt that was non-essential. All right, so here is what you have done so far. This is in your notes, and I am going to go ahead and use GeoGebra to kind of illustrate the new kind of learning. All right, here's what you have learned so far. You have talked about a central angle. And a central angle is one in which you have a circle, and this arc right here is the same measurement as your central angle. And it is a central angle because its vertex is in the center of the circle. So hopefully that makes sense. All right. So now if I place a point on the circle and now I create a new angle. So notice I'm still going to take where that arc is, that's highlighted in red, but now I'm going to go from B to D, and now I'm going to go from C to D. And let me measure that angle. So if I measure angle CDB, notice how it is 32.6. So let's see if we can figure out what the relationship here is. Let me try to see if I can get this to be a whole number. Maybe it'll work and maybe it won't. Let's see. Oh, almost. There we go. Oh, come on, go back to 64. There we go. All right, so I think this is where it is clearer to see what's going on. This angle is 32, and its vertex is on the circle. The central angle was 64 when the arc was 64. So whenever we talk about an arc that has been intercepted, if the vertex of the angle intercepting it is in the center, it is going to have the same measurement. But if the vertex of that angle is on the circle, that is what is called an inscribed angle, and it is half the arc. So that's what this opening part is saying. Right here, what I have in red ink, the red ink is the central angle. So if its measurement is 90, that means the arc it intercepts is also 90. But an inscribed angle is an angle where the vertex is on the circle. And when that occurs, that angle is going to be half of the arc, so that's going to make that 45. So that's what this says. If we have an inscribed angle, it's an angle whose vertex is on the circle and whose sides contain chords of the circle. An arc that lies between two lines, rays, or segments, that is called the intercepted arc. So what they mean is if I have a circle and I draw an angle, rays, segments where the vertex is on the circle, the intercepted arc is what is in between those rays, segments, or lines. And if that arc is 80 degrees, that means the angle that it is subtended is half of that. It's 40. And that's what this measure of an inscribed angles theorem talks about. The measure of the inscribed angle is 1/2 the measure of the intercepted arc. I always remember that the arc is bigger. The arc is always the bigger of the two values. So what does that look like in my homework? All right, they want me to find the measure. Hold on, having issues pinching. All right, they want you to find the indicated measure. They want to know angle T. So this is what they want to know. If I extend it, this means that is the angle, and it creates the arc that's 48 degrees. But since the vertex T is on the circle, that means it is an inscribed angle. So that means it is half the arc. So half of 48 would give me 24 degrees. All right, so for part B, they want us to find the arc of QR. And what I notice is there isn't anything in the picture that either has a central angle or an inscribed angle that cuts that off. So what I do notice, however, is I notice that this is a semicircle. That means I know from R to T, it's 180 degrees. Then I notice that QRT is an inscribed angle. So if the angle is 50 degrees, that means that I would double it to get arc QT. So that means minor arc QR would have to be 80 degrees. The next question, if I can pinch correctly, it wants you to find the minor arc of RS and the measure of angle STR. What do you notice about angle STR and angle RUS? Well, here's what I notice. Arc SR is cut by angle SUR. Since that is 31 degrees, I know that the measurement of arc RS is double that, so it's 62 degrees. What I also notice, and that's what the second part of the problem is alluding to, is that angle STR is cutting off this same arc SR. So that means that the measure of STR would have to equal the measure of angle RUS. They're congruent, and therefore that is also 31 as well. Next, we have the inscribed angles of a circles theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. And that's what this was talking about. So to kind of reiterate what went on here, if I look at arc SR, it is being cut off by two different inscribed angles. And according to the theorem, is those two inscribed angles would then have to be congruent. They're both 31 degrees. So in this problem, given the measure of angle E is 75 degrees, they want you to find the measure of angle F. So here's how you could do the problem without doing any math like calculations. I noticed that angle E, that cuts off this arc GH. What I also notice is that angle F cuts off the same arc. Therefore, those two have to be congruent, so the measure of angle F is also 75 degrees. So now let's do again some more example problems. They want us to find the measure of the red arc or angle. So on problem 1, the red angle cuts off arc H to F. If that's 90, that means the angle has to be half of that. So the measurement of angle G is going to be 45 degrees. On angle 2, this time they gave you the angle measurement and they want the arc. So that means I have to double it. So that means that the measure of arc TV is 76 degrees. All right, in this problem, they want you to find the red angle, and I notice that the red angle cuts off or subtends arc ZW, and so does angle Y. So that means angle Y and angle X have to be the same, so the measurement of angle X is also 72 degrees. A polygon that is, gosh, having some problems on the pinching today, guys. There we go. A polygon is an inscribed polygon when all of the vertices lie on the circle. So we would call this a circumscribed circle because it has an inscribed polygon. All right, and here are some more theorems. we have the inscribed right triangle theorem. So if a right triangle is in a circle, then the hypotenuse has to be the diameter. Think about this. In order for you to have a 90-degree angle, this has to be double that by our inscribed definition of an inscribed angle. So that has to be 180. So that's why the hypotenuse has to be the diameter of the circle. Next, a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So F and D have to equal 180, and E and G would have to equal 180. All right, so let's find the value of each variable. So if I am looking at problem A, and you notice that there is a triangle, since this is the diameter, we know that this has to be a right angle. So 2x is equal to 90. So that means x would have to be 45. All right, in this problem, we're going to use that second theorem, which tells us that if you have a polygon or a quadrilateral specifically, a quadrilateral that is inscribed in the circle, then that means your opposite vertices have to be supplementary. So that means D and F have to be supplementary. So that means Z is going to be 100 degrees. And that means that E and G have to be supplementary, so that makes Y 60 degrees. Let's do some more finding a few variables, and then we're about done. All right, so in this problem, I notice that this diameter is the hypotenuse of this triangle. That means this has to be a right triangle. Another way of explaining this is if you look at that inscribed angle, we know that the that the degree measurement of that arc is 180, so x has to be half of that. And then 40 plus 90 gives me 130, and when I subtract that from 180, that means y would have to be 50 degrees. In problem 5, we have a quadrilateral that is inscribed in the circle, and our theorem tells us that our opposite angles have to be supplementary. So I would get y by taking 180 minus 68, and so y is equal to 112 degrees. And then in order to find x and 82 have to be supplementary. So 180 minus 82 would give me that x would be 98 degrees. And our last example, okay, on this problem, we know that t and v have to be supplementary. So that means 10x plus 8x equals 180. So 18x is equal to 180. So that means x is equal to 10. Then, in order to find the other variable in the problem, which is c, since those are opposite angles of a quadrilateral inscribed in a circle, that means c plus 2c minus 6 is also equal to 180. So this gives me 3c minus 6 is 180. Add 6 to both sides, so 3c is equal to 186. And when I divide by 3, c is equal to 62. And now, please feel free to work on Unit 10, Lesson 4 practice. Please turn it into Google Classroom. Post by Thursday. Thank you.